Hello, and welcome to the Semiconductor Industry Association public webinar series where we discuss topics that are important to the chip industry. My name is Robert Casanova. I'm the Director of Industry Statistics and Economic Policy here at SIA, and I will be your host and moderator for today's webinar titled Partnership and Innovation: How Collaboration Between the Auto and Chip Industries Really Fosters Innovation and Drives Market Growth. Before I introduce our panelists, I just want to give a quick housekeeping. For Q&A, please make sure to use the Q&A function and not the chat function. For today's webinar, I'm really excited to introduce our group of panelists, starting with Andres Castrillon. He is the Director of Government Affairs at Qualcomm. Fern Yoon is the Director of Automotive System Engineering and Marketing for Texas Instruments. Greg Bassich is Associate Director for the Global Automotive Practice at Tech Insights. John Greco, Director of Automotive Market Insights for Analog Devices. Kristen Toth is the Executive Director for Electrical Systems, Software, and Connectivity for General Motors. So to kick off the webinar today, I wanted to pass it along to Greg to discuss his insights on market trends in the chip and auto industries in 2023 and a projection for 2024. So I'll pass it along to Greg.
All right, thanks so much, Robert. All right, so today I'm going to be talking about providing snapshots for some of the major trends that we're seeing in the automotive industry and how those trends are affecting the semiconductor industry, and a little bit about how those industries are working together. So, starting with vehicle production. So, Tech Insights licenses vehicle production data, which we use in our forecasts, from a company called Global Data. And this particular slide shows light-duty vehicle production and the differences between their forecast from earlier in this year for Q2 and their most recent forecast, which is from Q3. So for 2023, their view of global automotive production is a bit more optimistic at about 89 million units, which is about a 1.8% increase from the level they'd expected in the previous forecast. We'll see what happens with their Q4 forecast. Obviously, there was the strike earlier this year, which has for the most part been resolved, which will affect production slightly. But in general, we're probably looking at light-duty vehicle production of about between 88 to 89 million units. Looking ahead, the forecast is relatively similar compared to their previous forecasts. And by 2030, they're expecting vehicle production to get up to about 101.8 million units for that year. This obviously has a major effect on the semiconductor business. More vehicles means more semiconductors, and of course, more revenue for the semiconductor business. But production is not the only factor that's going to be influencing the semiconductor content in vehicles and the relationships between those two industries. This particular slide here, and this the text here describes the total revenue that automakers are paying tier ones for electronic systems and components going into cars. And there are various factors that could be affecting our particular forecast globally. If you look at the red bars, or the orangish red bar there, that's our standard forecast. So we're expecting approaching $420 billion of total global value for electronic systems in cars for this year, for 2023. And we're expecting that to increase to, it's not exactly $460 billion, but approaching $460 billion in 2024. The combined 2023-2024 system value, based on our current forecast, is about $873 billion. Factors that could affect it could include the current debt crisis in China, depending on how that affects consumer spending and, of course, therefore vehicle production. Also, with the ongoing war in Ukraine, in Europe, there could be production there could be flat. And in both of these particular situations could reduce the total amount of electronic system demand due to changes in vehicle production, slight decreases in vehicle production by a bit. So, for example, if the China debt crisis comes to a head, we are seeing a change down to about $859 billion as opposed to $873 for 2023 and 2024 combined. The Europe slowdown will be a much smaller decrease, only of about $5 billion down to about $868 billion. Obviously, if everything gets resolved and everything is wonderful globally and economically, then we may see a slight increase of about $5 billion up to about $878 billion of combined electronic system value. Now, this is having a major effect, will have a major effect on the types of semiconductors, especially based on some of the slides that I'll be showing in a minute. So two other major factors that we're seeing in the market include the rollout of electric vehicles, which is moving ahead based on our current forecast, Tech Insights forecast. We expect battery electric vehicle production to increase from about 8.17 million units in last year to about 38.35 million units in 2030. So we expect this to have, for example, effects on the types of power electronics going into vehicles, and of course on the overall system design, which we'll get to in a minute. And then for autonomous vehicles, this is not going as maybe as some people in the industry and companies had previously expected. What we've adjusted our forecast to reflect an increase in so-called SAE level 3 vehicles, which requires a driver to be in the vehicle and to be able to manage any kind of issues that the autonomous systems can't have. So vehicles with very advanced autopilot systems, we're not quite there yet in the market. They're definitional issues with L3 versus L level 2 in the market. But we're expecting that to increase from about 1.4 million units in 2025 to about 12.93 million units by 2030, which is still a relatively small percentage of total vehicle production. As for level 4 vehicles, which don't require a driver, they'd be totally hands-off and could resemble more like robotaxis, though level 4 vehicles are typically geofenced, so combined to certain routes and areas. We expect that to increase from about 300,000 in 2030 to about 3.83 million by 2035. So a relatively small percentage of vehicle production. One of the other changes we're seeing as more advanced technologies are going into vehicles, for example, into electric vehicles and more advanced safety systems in vehicles, is a major change in electronic and electrical vehicle architecture, so changes in EE architectures. For a long time, for most of the industry's history, most vehicles have had dozens and dozens and dozens of different electronic control units, each of which was relatively simple and managed a single or a small number of functions. And these diagrams are just very high level. They're not meant to represent engineering level diagrams, just to illustrate the concepts. But what we're seeing is a shift from distributed architectures to much more consolidated architectures, where you have a much smaller number of much more powerful multifunction ECUs that are called a variety of names: high-performance compute ECUs, central controllers, vehicle servers. It really depends on the company and their specific product, the supplier and their product. But a much more smaller number of these more powerful ECUs going into vehicles, and these powerful ECUs would connect to so-called zonal gateways. A gateway is kind of like an information router within the vehicle that will connect to sensors, and actuators would route information to the high-performance compute ECUs for whatever functions they would need. So example consolidation we're seeing in the market today would include something such as infotainment functions being combined with a growing number of safety functions, safety critical functions. This is having an effect on the types of semiconductors that need to be going into these systems and how the semiconductor industry is designing these new semiconductor products to support these types of systems, especially mixed criticality systems, where you have, say, non-safety critical and safety critical functions in a single electronic control unit. This last slide here is our view of global automotive semiconductor demand. So what kind of revenue we're seeing for the semiconductor market specifically in terms of the value of the semiconductors and semiconductor sensor elements that are going into vehicles being built globally. So Tech Insights expects the global market to go from about $54.7 billion last year to more than double to about $134.5 billion by 2030. In terms of major market drivers, we would expect safety to be one of the big drivers, especially as ADAS becomes much more capable and has much more requirements, going from about $13.2 billion last year to about $39.2 billion in 2030. We also expect powertrain, especially as we shift to more electric vehicles, to go from about $12.7 billion in value last year to about $18.1 billion in 2030, or sorry, looking at the wrong one. Looking at $13 billion in 2022 to $33 billion in 2030. And another new category, which I mentioned, is the zonal controllers. We expect that to go from about $511 million in 2022 to about $21.8 billion in 2030. So the idea here is that these particular categories are aligned with some of the major functions and growth areas that I outlined in the slides previously. So that's what I have today to provide a brief overview of some of the major trends we're seeing in the market. So back to you, Robert, so we can move on with the presentation.
Thanks, Greg. A lot of great information to really set the stage for the discussion today. before we start, I just want to make sure um, I want to give this backdrop for our discussion, at least our first round of questions. Um, as you mentioned, uh, the auto industry is really going to be a driver for demand moving forward. In the last 2 decades, the ICT markets have really sparked demand for innovation and driven demand for semiconductors uh, in the industry. However, the next decade, we expect to see those industries that have historically made up about a third of semiconductor sales revenue to really drive demand, including the automotive industry. So my first question is, what new technologies in the chip and auto industries are you most excited about? And what market trends do you all expect to see in the next 1 to 3 years? And to kick off this question, I'd like to pass it along to Fern.
Thanks, Robert. That's an exciting question to ask because we're certainly at a market inflection, I would say, within the automotive market. Today's vehicles can have anywhere from hundreds to thousands of semiconductors powering, sensing, and processing information to make vehicles safer and smarter. And, when I look at a car today, the vehicles are no longer being differentiated by just the engine performance, but also defined by the ability to provide more personalization, better in-vehicle experience, and next-level convenience features, which is why OEMs globally are exploring and embracing this concept of software-defined vehicles, which in turn requires a lot of new innovation in the semiconductor market. This requires a much closer collaboration than ever before between the auto makers and semiconductor suppliers to enable this goal. And the innovation that comes from there, it can be seen through the processors, the types of processors that go into vehicles today. Certainly power management, thermal management with that requires a significant amount of power. Electrification of the vehicle, moving from a combustion engine to electric motors throughout the cars. And then Greg talked about electric vehicles. There's a whole slew of new technologies that go into making the batteries more efficient, safer, converting the energy to propel the vehicles forward. So these are all new innovations and market trends that we can look forward to in the near future.
Thanks, Fern. Andres, what are you most excited about?
Yeah, thanks so much, Robert, and thanks to SIA for the invitation. I echo everything that Fern said. I think from a Qualcomm perspective, what excites us most is just the pace of innovation, the pace of transformation, and then specifically the digital transformation that we're seeing in the auto industry. You've already heard the auto industry is transitioning towards electrification. We're seeing really innovative new advanced driver assist systems, and then increasing levels of autonomy. And then as Fern just referenced, from a consumer perspective, the consumer is really demanding really new features in terms of personalized in-car experiences and a seamless experience in the vehicle with their personal devices. And so, from a technology company perspective, we know that all of this is going to require an increasing level of compute power. It's going to require advanced semiconductors, but the silicon is not important in and of itself. It's going to require companies that can combine that silicon with software and really enable automakers to look at redesigning and redefining what the electric architecture looks like in the vehicle, what the digital architecture looks like in the vehicle. The car, as Fern mentioned, has really become a connected platform on real wheels, right? Like similar to your cell phone or your computer. And so what this does is it gives us an opportunity as technology companies and automakers to sort of rethink what the vehicle looks like, both inside and outside. What does that digital architecture look like? What does the electronic architecture look like? What do consumers want? And then how are automakers going to differentiate themselves in this era of software-defined vehicles, as Fern mentioned? So for a technology company like Qualcomm, it means a really cool opportunity for us to have much deeper relationships and technology partnerships with the automakers and offer new products and services, and really looking at enabling, offering them a platform for innovation, which is what Qualcomm does with its Snapdragon digital chassis platform. And then for the automakers, I think it's more important than ever for them to make sure that they've got the right technology partnerships in place. So it's really that pace of innovation and that digital transformation that excites us most.
Thanks, Andres. John, how about you? What's most exciting for you?
Oh, thanks, Robert. I think people have touched on many of the items already. I think this idea that the car is becoming an intelligent companion, it's fully integrated with the driver's digital life, for example. Safety, the cars are definitely becoming safer, and to some extent, even if the level of autonomy doesn't increase, I think it's pretty clear that you're still going to be providing drivers with a lot more data that they can use to make better decisions, regardless of what the level of autonomy finally turns out to be. So I think one of the things that's really important there is that there's a lot more collaboration, a lot more transparency, I think, going on between OEMs, tier ones, and semiconductor vendors across the ecosystem to try to make sure everybody's aware of and is able to deploy new technology and new innovation a lot more quickly than it's happened in the past in the automotive space. So there's definitely a very competitive aspect to it in terms of people trying to get things out there. And I would agree with Andreas about the idea of a platform. I know, for example, from like some of the things we're excited at Analog Devices, for example, would be some of our networking platforms that create a framework in the car that you can start to hang new innovations off of very, very, very quickly, and can quickly go from one generation to the next, speed increases, et cetera, and be ready to add new features and new things quickly.
Thanks, John. Kristen, what are you most excited for in the automotive industry and innovation within the semiconductor industry?
Yeah, thanks, Robert, for having all of us here this afternoon. And, I echo all of the comments that have been made so far, and I can't reinforce enough some of the comments on relationships and partnerships and how important that is today and how important that's going to be, in the future here as technology advances, which is pretty exciting in itself. I'd say, over the past few years, we've really grown at General Motors to get much closer to each supplier throughout the supply chain. And it's really been, something that is helping us propel our future for sure. So, as industry moves towards EVs and advanced driver assistant technologies, we really see the requirements almost doubling over the next several years, which again is pretty exciting in itself. The growth is massive. And in order to do that, we really need to reduce the complexity and try to, create and use this as an opportunity to increase the scale while simplifying. So, for us at General Motors, we really see this as opportunity more than anything to set up our future architectures right in a way with the right partners, with the right technologies, in creating it in a way that's not as complex, and we have a little bit more, control on the semiconductors themselves. So, we're doing that today. We're reducing the complexity significantly. One example in microprocessors alone, MCUs, we're reducing by about 95% the types. The numbers are still there, but the types are reduced. It helps us increase the scale and helps us keep really strong partnerships. And in order to do that, we have to be able to focus on different core families of chips. And so that's, something we're pretty excited about as well. And I'd say also, things that are happening at General Motors that we're excited about is we've just, internally made significant changes over the past few years. For example, we have an engineering team specializing in silicon. We formed a center of expertise around shaping and managing some key agreements. We're reassessing our product development and engineering to simplify the electronics overall and the software architecture where possible. So, these are the things that we're working on at GM, and definitely aligns to all the previous comments.
Thanks, Kristen. And to round it off, Greg, what are you most excited for in the space?
I don't think there's really one specific technology that I'm excited about. It's just what excites me about what's going on in the industry, period, is the sheer number of changes all colliding at the same time in the industry that everybody is trying to adapt to. If you look at the semiconductor business, there's been huge focus, because I've been doing this for about 10 years now, on creating products that are much more aligned with the future changes in the industry. So some of the changes I pointed out in my slides, for example, the change in architectures, you can see how companies like Qualcomm, for example, are already Texas Instruments. They're focusing on different areas of these next generation vehicles and architectures in order to support the types of features that automakers ultimately want to provide. So it's, like I said, it's hard to say one particular technology is dominant. I would say one that's probably like maybe stands out for me is it's becoming more interesting how companies are adopting AI for example, for safety-related systems development and for actual for the vehicles themselves. There have been a lot of changes, for example, around vision processing that have been really interesting over the last few years. I'd also say that we're beginning to see generative AI making its way into the cockpit. We'll see how that rollout goes. Obviously, generative AI is a hot topic in the industry, very broadly speaking. And you've already had some automakers, for example, GM, that have been talking about incorporating that with next generation digital assistants in vehicles. So like I said, those are some technologies that excite me, but it's really just the collision of all these technologies at the same time in a very short period of time, especially by automotive industry standards, that's exciting.
Great. You know, moving along, there's been some similar features that all of you had mentioned in your answers, and one of them being safety, right? The innovation in safety being a major part of the collaboration between the automakers and the chip industry. So, you know, when we look at vehicles on the road today, they have the basic, the advanced driver assistance systems, those ADAS. However, you know, more advanced automotive driving systems that would allow drivers to have more freedom while on the road is considered an area that can provide, by one estimate, about $300 billion in revenue in the auto industry in the next decade. So I guess my question is, what do you see as the most innovative technology in this space, and how are these two industries working together to capitalize on this potential growth? Let's start with Andres.
Yeah, thanks, Robert. And this is a really important question, and maybe I'll reframe it a little bit, because I think when it comes to safety, certainly there's some opportunity for increased revenue, but we have a public health crisis on our roadways here in the United States, right? So roadway fatalities are at or near all-time highs. Fatalities for cyclists and pedestrians are at all-time highs, and you know, that's a problem that collectively the industry, you know, needs to resolve. We need to figure out a way to reverse that trend. At Qualcomm, we believe very strongly that connected vehicle technology is a big part of the solution, and specifically a technology called cellular vehicle to everything technology, or CV2X. At a really high level, this is a technology that allows vehicles to communicate with other vehicles, or V2V communications, and vehicles to communicate with infrastructure, or V2I communications, and then down the line, vehicles to actually communicate with pedestrians and other, you know, cyclists and other vulnerable road users. So you can imagine in a world where vehicles and infrastructure are connected, that we can coordinate our movements in a way that allows us to either, you know, eliminate or at least mitigate a significant amount of crashes and accidents, and really start to reverse that roadway fatality trend. Robert, you mentioned some of the ADAS technologies that are on the road today. What really sets CV2X and connected vehicle technology apart from those ADAS technologies is the ability to identify potential crashes or potential hazards outside of the line of sight. So literally the ability to see around corners. So when we talk about V2V communications, or vehicle to vehicle communications, this is a simple "I see you, you see me" message. Let's not crash into each other. Really impactful in scenarios like a do not pass warning, or a left turn assist at a blind intersection. Again, getting these alerts that give you a higher level of informational awareness, and allow you to identify hazards that aren't within your line of sight. So the technology is not meant to replace ADAS. It's really meant to add another critical layer of safety redundancy. We're really excited about this, not just because we think it's going to be impactful, but also because we're seeing some global momentum. We've seen a bunch of automakers announce plans to deploy this technology in China, and that's largely been driven by China incorporating V2X into their NCAP roadmap, their new car assessment program, or their 5-star safety rating program. And so China right now is really leading the way towards deployment. But here at home in the US, we're also seeing a significant amount of momentum. So as we sit here today, there are 15 states that have received permission from the FCC to deploy for a variety of use cases. And then a really exciting development in the last month from the US Department of Transportation, which has just unveiled a draft national V2X deployment plan, which includes some benchmarks and targets for both automaker and infrastructure deployments. And so we think that federal leadership and convening the industry together to talk about moving forward with deployment collaboratively is really going to move the needle terms for early stage deployments here in the United States.
A lot of great technology there, Andres. Kristen, what's your take on this question?
Thanks. Obviously safety is so important to all of us, all of our companies. It's a priority for everyone. And there is so much happening in this space in terms of technology growth. And it's really about the customer experience and what value that can bring. And, I'll just, focus a little bit on General Motors Super Cruise hand-free ADAS system. It's been a significant step in our journey, and our journey with a goal towards zero emissions, zero crashes, and zero congestion, which obviously gets back to just a much more safer environment for all of us. Super Cruise, it's the industry's first true hands-free driver assistant technology. It enables us to travel and drive hands-free. It's available on over 400,000 miles already in the US and Canada. We'll be expanding that for sure. Super Cruise uses 2 different advanced technology systems. It's a driver attention system and a precision LiDAR map data. And the way it works is when it's engaged, the vehicle's precision LiDAR map data and real-time cameras, radars, GPS keeps that vehicle traveling along the lane path for a hands-free driving experience, completely hands-free. You do have to be looking. These systems work together through the sensor fusion. It creates a sensory field around the vehicle that assists in keeping it centered in the lane, so you're not veering off. And that's really something that gives our customers comfort and convenience. If you haven't driven a vehicle with Super Cruise, it's really, really exciting to drive it. And it's something that our customers absolutely love, and we know they love that. We have the data, and it's the second most attractive feature for a customer when they go in to purchase a vehicle, and that follows their brand is the leading reason. So it's number 2. So we know our customers love it. It's a fantastic technology, and already on the road today we have more than 120 million miles total driven by customers using this advanced feature called Super Cruise. And again, we'll be expanding that too.
Great, thank you, Kristen. I'm actually now excited to try Super Cruise when I have a chance. John, how do you see the safety features, innovation moving forward?
I'm with you there, Robert. I want to get behind the Super Cruise vehicle now too. So I think those are all great points. I think one of the things I'd like to focus in on is what has to go on behind the scenes for those things to be successful. There's an awful lot of data being transferred around the vehicle in those situations. There's a lot of data being collected by sensors. It's being sent to different points to be processed, whether it's processed at the edge or whether it's processed in a central computer. Again, you need to do a lot of data transport. You're also starting to operate now in a much more power limited environment, I think, when you start to look particularly at EVs. We have a battery, and you're actually starting to drain the battery to do some of these things. So from the analog devices perspective, 2 of the areas that are really exciting to us is the ability to have efficient, light, effective links. And so, for example, we have the gigabit multimedia serial link that we have been very successful with. That's proliferating over 600 million links on the road, and we keep increasing the bandwidth on that because people keep demanding more bandwidth because there's more and more data, more and more displays being sent, more and more sensors being transferred around the vehicle. And then on the other side of it, there's a really interesting opportunity to manage this power more effectively, to make the power budget now has become a big problem in automobiles, more so than it was in the past. And so paying attention to that, it has to be paid attention to now at the system level, as opposed to just at the system level being the whole vehicle, as opposed to just looking at the individual system or the individual box, so to speak. So that's a really, that's some of the stuff that has to go on behind the scenes to enable some of this. And that's something we're pretty excited about. And it's growing and you know, is developing and innovating today.
Thanks, John. Fern, what's your take?
I think this is an exciting topic because as drivers, as you know, people who drive actual cars, this is one of the more perceptible things that you can see in the evolution of technology towards autonomous driving. I agree with everything that the panelists have said, but what I would say is that the big thing that really stuck out to me is just the various ways that you can achieve this level of safety. Every OEM does it in a slightly different way. Kristen mentioned, you know, leveraging LiDAR, radar, camera. There's so many types of sensors, so many approaches and algorithms that you can use to stitch it all together to make it a lot more intelligent. And, you know, what we, and Andreas talked about the connectivity to the car. What people don't see as much is the surrounding analog that needs to go around that as well. John mentioned Bravely Power, you know, the power efficiently, safely, securely is going to be really important, as well as being able to fit in these smaller spaces as the density increases is one aspect of it. The other aspect of it is also more and more accurate sensors. You're going from a 2x2, 4x4 radar array to now, you know, conversations around a 16x16 or a 32x32 radar array for better accuracy to be able to anticipate incidents before they happen. These are all technologies that TI is also investing in, whether it is enabling radar sensors, ultrasonic, LiDAR, camera sensors. How are you connecting or sending this data from the sensors to the processors that are making these decisions? How are you providing the power surrounding it? It really does become a system level challenge that we're very well positioned to solve with just our broad portfolio here. The other aspect of it is as you have more and more electronics in the car, we talk about safety and just the criticality of how it prevents, the intention is to prevent incidents from happening or reducing the number of incidents from happening. We also need to make sure that these systems are secure. So TI is also not only investing in functional safety capable systems, but also really digging into cybersecurity, another aspect that becomes a challenge for automakers to address as more and more electronics go into the vehicles.
Thanks, Fern. And Greg, what do you see as a innovation in the technology space for safety?
So one of the things that I think kind of ties back to discussions around the in-vehicle architecture changing that I found pretty interesting over the last few years is how many semiconductor companies, Qualcomm being one, for example, you have NVIDIA, there are others, that are focusing on developing semis that have mixed criticality functionality. So they can support, for example, infotainment, and they can also support safety or critical functions. And one of the changes that I think I've seen over the last few years is a move from simply supporting something like, say, ASIL B levels of safety criticality, where, say, it's just the instrument cluster information that we presented to the driver on a single SoC, to, in addition to infotainment and other functions, also supporting now moving toward ASIL D. So the most safety critical operations could be safely sort of sandboxed, maybe one way to put it, and run on that same particular product. Another change, and this is kind of more at the semi level that's been pretty interesting and is fairly recent, is the move towards so-called automotive grade chiplets. So in the broader semiconductor industry, there's this idea that you could manage, rather than having a single monolithic SoC that does everything, you could have a processor that has many different types of IP blocks, many different components that where each component could be managed, could be manufactured at a different process node. And for example, in the auto industry, as mentioned, we have kind of a mixed need for both digital and analog systems on these devices. So I think those couple of technologies have been pretty interesting to watch. And like I said, I think chiplets is one that is particularly exciting because I'm interested in seeing what that will enable for next generation systems.
Thanks, Greg. So, one of the things that was mentioned within the safety feature is also the idea of connectivity, right? There's more demand for connectivity between the driver, the vehicle, and the surrounding landscape. And this has really grown in the past few years. Drivers want the ability to have individual user experiences within their infotainment system, cloud capability to see car statistics on their phone, and really better communication between the car and its surroundings. So given the growth in the consumer demand for these features, can you describe what new innovations from the chip industry will help the auto industry innovate in this space, and how will the auto industry, or how does the auto industry expect to incorporate these chips in their new vehicle technologies moving forward? Kristen, how about you start with this question?
Yeah, thanks, Robert. No doubt about it. Software and software-enabled services will continue to play a major role in technology and the customer experience. We see continued innovation in areas of personalization, performance enhancement modes, apps, sensors, sophisticated sensors, connected camera systems, and overall vehicle health monitoring. So, in order to deliver these type of features and technologies, our vehicles require the increased compute power, faster wired and wireless networks that help that higher resolution, sensors enabled by advancement and chip technology, et cetera. It's exciting, and we do need all of those items. One example for chip technology advancements are contributing to improvements are, like I mentioned, in Super Cruise, the hands-free driver assisted, technology. It relies on camera, sensors, processing power. Another one, vehicle data, sensors and camera, all integrated with AI decisioning that's being used to provide new services to enhance our active safety, environmental recognition, and to help reduce driver distraction. Several others, new infotainment applications that bring drivers, conveniences and entertainment options while you're parked, such as real-time nav, video streaming, things like that. All those customer, attributes that we want for the customer, experience. And, our expectation is that our vehicles will continue to receive new software updates and features delivered over the air, and that's going to happen during the ownership life cycle beyond the initial vehicle purchase. So pretty exciting things coming from a connectivity perspective.
Thanks, Kristen. John, how do you see technology moving forward in the connectivity space?
No, I would agree with everything Kristen said in terms of the variety of connections that are needed in a vehicle today. From the analog devices perspective, we focus a lot on doing that networking within the vehicle itself. And what's very interesting is there's still no one bus that can do it all. You need buses that cover the network backbone. You need networks that cover the edge sensors. And so that's where there's a lot of innovation taking place today in creating in-vehicle networks that are smaller, that have fewer wires, fewer weight. For example, analog devices case, we have a couple of buses. I mentioned GMSL, which is a higher speed bus, but then we have a to B bus, which is focused more on focused on audio, and is now being focused and taken out to more applications such as road noise cancellation. All of these things that are new applications that need to be hung off of this in-vehicle network framework. And again, these vehicles, I would say these buses also have to be safe. That's another area where the semiconductor industry has got to focus on making sure these things have some degree of resilience in them and can handle real-time data streaming and have some degree of cybersecurity and safety associated with them as well.
Thanks, John. Fern, how is TI really, driving innovation in the connectivity space?
Yeah, this is another interesting topic. TI, similar to ADI, does have a variety of wired interfaces that we continue to invest in. You have the standard CAN LAN that has a lot of value, and we see the market moving to higher bandwidth interfaces such as Ethernet or the FPD link, the GMSL version. For these high-speed data for images as well. Then you also see the wireless piece coming in. I've gotten spoiled by the wireless car access. Not having to fish my key out of my bag every time I need to unlock my door. And we see that capability expanding in the market to include not just being able to open your door, but also using that same technology to sense occupants in the car to make it safer, to be able to send data back to the cloud to notify the driver if something is amiss. Kristen also talked about the concept of over-the-air updates, which kind of goes hand in hand with software-defined vehicles, in addition to the communication standards that drive, what we consider traditionally for communication and connectivity. We also see a big pull from the car makers to make upgrades to vehicles, whether it is major platforms or, as Kristen mentioned, additional incremental features that we want to be able to deliver to the drivers to make it easier and more cost effective to be able to do so. So there is also a focus that we see on modularizing software and the way the software interacts with the hardware so that we can continue to provide better hardware or hardware upgrades, if you will, without necessarily having to redesign the entire software stack, which from my understanding is very expensive and a significant amount of work. So how do we get smarter and more efficient in continuously be able to provide drivers with a better experience, more personalized feature sets without necessarily having them to go to the dealership every time they wanted to add a feature or remove a feature. So that's the other aspect that TI is also looking and investing. We're looking at it from a holistic approach. We're not just looking at it from a semiconductor silicon hardware investment, but also the ecosystem. How do we enable our customers to leverage our technology more seamlessly and more efficiently?
Thanks, Fern. I also have to confess, I like the idea of being able to open my car without fishing for my keys. Andres, how is Qualcomm, working within this space?
Yeah, so this is right in our wheelhouse, right? Because connectivity is at the core of everything we do at Qualcomm. We've been a leader in telematics for over a decade. We've worked with just about every automaker to enable 3G, 4G, and 5G connectivity. But in terms of more recent innovations, our focus has really been on making sure that the platform, the digital chassis platform that we provide to automakers has a comprehensive car-to-cloud services platform sort of built into that. And so it's enabling that car-to-cloud connectivity to support a full range of applications and use cases, a bunch of which have already been mentioned. So, things like either updating or enhancing, providing updates to different technology or safety packages, providing new forms of virtual assistants, simple things like, Wi-Fi hotspot enablement. And then Kristen mentioned, things like providing on-demand streaming of different digital content for the passengers in the vehicle. And so, our focus has really been on providing that platform for the automakers. And, I think what's most impactful and innovative about that is that, and it's been referenced already, is the path to a product that is upgradable over time. And allowing automakers to offer a product to their consumers that is really future-proofed and that can be customized and updated over time, and really also providing an opportunity for automakers to sort of redefine their relationship with the customers, looking at potential new offerings or revenue streams, and then from a consumer perspective, really changing the car buying experience, knowing that you're buying a product that's upgradable and customizable over time.
Thanks, Andres. Greg, what's your thought on this space?
So all of my industry colleagues here have pointed out kind of the major changes we're seeing in connectivity, a shift to much more widely available connected services. If you take a look at some of our research, we're currently tracking 422 different combinations of country and OEM brand worldwide. So you have all the automakers in this many automakers in Germany, this many in China, this many in the US. That's how many there are. So it's a global phenomenon in terms of connected services deployment. And of course, these connected services are now involving over-the-air updates and the continual delivery of services and new types of software updates going forward. I think one of the things that's kind of interesting from a technology perspective that we're beginning to see make its way into at the silicon level and just at the service level is satellite technology. Satellite's kind of in one of those areas that's long been this idea that you could use it to provide additional coverage, because as we move into a world where vehicles are connected, what do you do about rural areas where you just don't have the same level of connectivity you would have in urban areas, or for example in urban canyons, areas where connectivity can be more difficult? Or what do you do if there's, for example, like a concert or some other event that's blocking connectivity, say from cellular connectivity in an area? I think satellite's an interesting way to be able to mitigate some of those issues, and we're beginning to see some companies, for example, Qualcomm, that are looking at figuring out ways to incorporate satellite connectivity into the systems in cars in order to provide connectivity. And of course, this is also being enabled by a lot of the new small satellite constellations, the low Earth orbit constellations being launched by a pretty wide variety of companies out there. We have companies like Starlink, which is part of SpaceX. And we're going to see more of that in the years to come. So I think in terms of new technology, satellite's kind of one that's pretty interesting to me, and I'm curious to see how that gets incorporated into cars going forward.
Thanks, Greg. You mentioned, I want to shift gears, but in your presentation, you mentioned, the growing electrification of vehicles, right? Hybrid and electric vehicles are standard options for consumers now, and the increasing electrification of vehicle demands more advanced technologies. How are these industries, the chip and auto industry, partnering to find innovations on high voltage battery systems, including wireless battery management systems, better charging, optimizing vehicle performance on the road, and again, enhanced vehicle safety? How about we start with you, friend?
Sure. Thanks, Robert. There's a lot of complexity that goes into a high voltage battery system. The first of which is in the name itself, high voltage, right? We're talking about 400, 800 volts, and that in itself poses a safety risk. From a TI perspective, we're investing in a wide array of products that can really help mitigate some of the risks from a high voltage perspective with regards to isolation, with regards to semiconductor relays that offer a safe disconnect much quicker than a mechanical relay between the high voltage battery and say the rest of the vehicle or the chassis in the case of an accident. But we also have power electronic devices that can handle those high voltages, convert them down into lower voltages that the rest of the car systems or electrical control units are more used to seeing or are designed to accept, such as 48, 12 volts, 5 volts, and even lower. The other aspect of it is the power consumption and being able to drive this high level of power density in a much smaller space. We don't want vehicles that are buses in order to be able to get the distance and the range and the voltage and the power that we want to be able to drive a certain distance. And so there's an aspect of power density, efficiency, and space that we continue to drive innovation there. Of course, we have to also talk about the battery management systems. one of the things that has come a long way with regards to electric vehicles is just the expanding range that you can get on a particular charge for an electric vehicle, and that continues to increase and improve as battery management technologies continue to improve within the semiconductor industry. TI's latest generation of battery management systems offer a high level of accuracy that allows the car makers to really optimize what that battery pack looks like that goes into the car, and to be able to really get a better prediction of how much charge do you have left in the battery, and to be able to optimize that distance. We also see the trend to go towards, say, a cheaper battery pack, because and that in itself comes with some challenges with regards to accuracy that we're able to address with our newer technology within the BMS chipset as well. Then you have the challenge of charging. When you go and refuel your car, your combustion engine vehicle today at a gas station, it may take you 5 minutes to fill your tank up. Right now, with the fast charging or superchargers that are available, it can still take up to 20 minutes, 30 minutes to get a full charge on your car. And so that is another challenge that we see the market trying to address. How do we get those charging times lower? And by being able to deliver more power safer to the vehicles during charging, and TI is investing in multiple different technologies to enable that as well.
Thanks, Fern. Andres, how is Qualcomm fitting into the electrification space for vehicles?
Yeah, thanks. I think Fern did a really, really nice job of explaining sort of the importance that the semiconductor industry is going to play in the electric vehicles themselves. And so maybe I'll take this question in a slightly different direction, because I think a lot of attention has been paid to the role of semiconductors in new EV platforms, and which is why I think you've seen a lot of the really innovative new concept vehicles when they get announced. Typically, there's an entire section in the announcement about which semiconductor company that new EV platform is going to be enabled by. The Afeela, which is a really cool concept vehicle that's designed jointly by Sony and Honda, is an example of that, where really cool, unique way of designing a vehicle, but also enabled by Qualcomm Snapdragon digital chassis. And so I'll sort of set that aside and focus on something else, which is that I don't think nearly enough attention has been paid to the really critical role that semiconductors are going to play in providing the EV charging infrastructure that is going to be necessary as we see EV adoption increase, right? And so when you plug your vehicle into charge, a lot of people don't realize there's a lot of data that's being communicated back and forth. And that communication is enabled by something called a PLC chip, a power line communication chip. And those are powered by Qualcomm chips and by chips from other semiconductor companies. If you think about the experience of an EV driver, right? Fern mentioned going to a charging station. You're going to want to know where the nearest one is, and you're going to want to know that it's open and not in use. And so that goes back to the last question on connectivity. You're going to want that information in a reliable and seamless way. When you get to the charging station itself, that charging station is going to have connectivity as well. It's going to have car to cloud, or infrastructure to cloud connectivity to perhaps process your subscription, whatever that may be, maybe process your credit card payment. It may also have a Wi-Fi modem, right? It may want to offer you a Wi-Fi hotspot so that you can be productive during the 20 or 30 minutes it takes to charge your vehicle. All of those technologies are enabled by semiconductors. And so, what I would say to add to Fern's contributions is that semiconductors are also going to be incredibly critical to making sure that we've got the charging infrastructure available and reliable in order for EV adoption to continue to increase at the rate that we're seeing.
Thanks, Andres. John, what's your take on electrification or the growing electrification of vehicles?
I would echo what both Fern and Andres said. It takes a village of parts, a village of a portfolio of semiconductor parts to electrify a vehicle. I would like to home in on the some of the partnership that has to go on. I mean, if you look at EVs today, probably the most critical short-term need of EVs is to bring down the cost of the vehicle, to come up with lower cost vehicles. They are expensive. And so how do you get there? Well, the biggest driver of cost in a car is an EV is the battery pack. And so you look at all the different ways you can innovate and some of the partnerships that have to happen to kind of reduce the cost of that, reduce the cost of the battery pack. One example I was going to use is wireless BMS. I think you had it, Robert, in your initial question there. But you take a look at wireless BMS. So most EVs today, they use wired BMS, where you have a physical connection between the modules inside a battery pack. And it's very well understood, it is reliable, but it also adds weight, space, and cost. Which is obviously the enemy of range in an EV, right? So wireless BMS removes the wires that connect to the modules, and it replaces them with radios. And as a result, you get a lighter vehicle. You can actually reduce the wiring by about 80%, eliminate the cost of that wiring. You can eliminate about 15% of the volume of the battery pack. And obviously, in a car, people will figure out something good to do with an extra 15% of space. But to get there, there's a lot of partnership that needs to happen between the car maker and the semiconductor company. From our perspective, we have to provide a full stack of software. We have to be we have to have a strong understanding of the ecosystem in which the OEM is operating. So, for example, it's not just a technical problem to implement wireless BMS. It introduces changes on the assembly line, changes to the manufacturer's processes, and you have to be able to partner. The different firms have to be able to work together, partner, and understand the implications of a new technology, of a new innovation. It might have nothing to do with the changes that may need to be made. It may not have much to do with the actual technology themselves, and may be related to processes, for example, the assembly of the vehicle. So, to successfully, and we've had successful implementations of wireless BMS at this point, and we've learned that is one of the types of partnerships that are happening now to rethink things, not just from purely a parts and components standpoint, but from the entire holistic view of the vehicle and even how it's assembled and built.
Thanks, John. Kristen, how is GM handling the growing consumer demand for electrification of vehicles?
Yeah, thanks. I will just kick this one off with, just getting down to the punchline here, which is, how are we working with our partners today? What can our partners do or suppliers do to give us the ideas? And we are open to collaborating with all suppliers throughout the supply chain. So contact us, bring us your ideas, all tiers. We're open to that. We have an advanced technology team, and I encourage the supply base to contact myself or my team. Just going back to what we're doing and how we see things. While we deploy hybrid in other markets and we're assessing potential future investment, our main focus in the U.S. is still an all-electric future driven primarily by EVs. We've deliberately created a modular, flexible propulsion system with our Ultium platform. It enables 2 different chemistries and even cell form factors with the same underpinnings. And that's to be optimized for the needs of local markets. And while there's synergies between global PHEVs and EVs, we will look to achieve efficiency and then, of course, overall cost improvement when possible. Very, very important. The innovation in the EV space just comes from so many different places, as all of us, I think, have mentioned. And, on opposite ends of the spectrum, we're seeking both increased energy density and cost reduction. So, for key components such as inverters, switches, future technology, things like that, we're exploring compound semiconductors, and other technologies that really achieve a balance of both objectives. And again, how are we partnering? We're working with our current supply base right now and always open to the suggestions and the ideas and the technologies that the entire supply base can bring forward.
Thanks, Kristen. Greg, how do you see consumer demand for electrification in vehicles going?
How do we see consumer demand? I mean, that's very much a country by country specific proposition. In China, there were incentives and there still are, but it's a definitely more, I think, more general consumer interest in China from what we've seen. In Europe, I'd say there are some countries where they're moving to pretty much majority EVs. That's happening largely due to regulations. So in some cases, it's more of a regulatory issue where saying, okay, this is what the government wants to do, and this is what we believe we should be doing, like in the EU, largely to address emissions and climate change. So it's in the U.S. It's been a bit of a bumpier road. I forget which one of my colleagues here, but mentioned the cost of EVs. So the cost of EVs is a challenge, and I think that's led to a bit of a slowdown in the U.S., especially as we're looking at, if you look at economic conditions going forward, it's unclear whether we're going to go into a recession or not in the next year. But that uncertainty, I think, is weighing in a lot of companies' minds, a lot of people's minds, a lot of consumers' minds. So because of that, I think we've seen a bit of a slowdown. So the industry does have its work cut out for it to reduce costs and get some of these vehicle prices down. It's difficult when you're trying to adopt many, many types of new technologies all at the same time. So I do see demand probably picking up eventually, but I think we do probably need to get through at least in the US, some of these economic headwinds until we have a better picture of where things are going. Either we have a recession and then it's a short one and things kind of bottom out and then we can kind of move up and go from there, or we'll see a bit of a pullback for a little while. Really kind of depends on how the economic situation globally plays out in the coming year.
Thanks. So we're gonna move on to a different subject. We know that during the pandemic and other supply chain shocks, it really had an impact on the automotive industry from the closure of fabs. I guess my last question is, how have the two industries really worked together or collaborated to help mitigate, future risk in the supply chain? Kristen, how about we start with you?
Thanks. I appreciate that question, Robert. I probably could talk for hours on this one, but I'll try to be brief. I mean, so much has happened over the past few years, and man, we have been through a lot as an industry altogether. I will say that it's been quite the roller coaster for sure. I had the opportunity to lead our semiconductor strategy through the shortages and work with many of you here on the phone and in the audience. And fortunately, we really tried to use that as a complete opportunity to set things right for the future, and gotten deeper into the supply chain, the value chain, into our relationships, and that's important, and that's not going to stop. We're going to use this as really a springboard to make sure that we continue to do that and continue those relationships for sure. In the past, we really focused a lot on a tier one relationship, and we've learned that we've got to do much more, and we've got to do that all together. And we've done a lot of different things with our supply base. From an agreement perspective, we've done agreements where we've actually had them right with the fabs themselves, which is very different from before. We've set up a whole team here in purchasing and engineering to manage all this quite differently and to reduce the risk. And to be honest, we're not done yet. There's so much more work to do. We can't take our eye off of this at all. We've got to make sure that we have a really resilient supply chain and be able to work with all of our suppliers in the supply base to increase the transparency throughout the supply chain and make sure that all of us know which in all of our devices and modules, that we have everything mapped accurately. It's a big challenge for us as an OEM to make sure all of our suppliers have the electronics mapped in the devices so that we know where they're located and how we can help the resiliency. Multiple locations for semiconductors is top focus for us. We've got to make sure that we have a resilient footprint. So, we really do need that help from the supply chain. And again, much more work to do here. We're not done yet.
Great. Fern, how is TI managing its relationship with its consumers to help mitigate those risks?
Yeah, as unfortunate as the supply constraints environment was, I think it really opened the door for better communication, more communication, and ultimately stronger collaboration between the car, automakers and suppliers like semiconductor suppliers like TI. There's been a lot of conversations educating each other around how the order process works, demand signal, supply chain responsiveness, and just the overall tools that we have in place that, to Kristen's point, just better transparency on both sides, to be honest. Certainly has a lot of room for improvement, but the conversations have started, the work has begun. And so I am hopeful that this will lead us to a much better place the next time the semiconductor demand increases significantly. In addition to that, TI is also making significant strategic investments to grow our 300 millimeter wafer fab manufacturing in the US, as well as expand our assembly and test sites worldwide. Continuous expansion, modernization, and automation. These investments are part of TI's long-term strategy to build manufacturing capacity to support, customer growth for decades to come. If you've analyzed semiconductor market data over the past 40 years or so, there is a cyclical nature to the semiconductor demand, and it has been on average about 40 months from peak to peak. And so when we trend that piece out, it looks like we will be fulfilling this capacity that we're building out ahead of time in not too distant of a future. So that's how we're planning ahead to support our customers as well. And owning our own manufacturing really provides us greater control of our supply chain, of our current footprint, roadmap, diversity, challenges, natural disasters. These are all things that our customers look for in suppliers that they can rely on. And that's where we're investing so that we can offer dependable capacity today and in the future. And there's a question in the Q&A that I'll touch on about obsolescence, semiconductor obsolescence. TI is actually putting a lot of effort into refreshing and redesigning some of our older portfolio, because we see the longevity that comes with these products, moving them from 150 or 200 millimeter fabs to 300 millimeter fabs to ensure longevity, but also to increase our efficiency in cost as well as in throughput that we can then continue to pass on to our customers.
Thanks, Fern. John, to you.
Thanks, Robert. I would agree with everything that's been said. I think, if you look at analog devices, we're also making investments in the global hybrid manufacturing model to, further enhance our supply chain resiliency. I think one of the biggest changes that's come about after the supply crisis was this idea of transparency, this idea that everybody now has been working hard to gain a better understanding of each other's supply chain, what the constraints are, what the conditions are, how to make it work, how to make it all work better as a team, so to speak. And, I would agree, it's still a work in progress. There's a lot more work to be done, but it's definitely better than it was. And I think we'll be better prepared for the next one that comes about.
Thanks, John. Andres.
Yeah, I don't want to, I'll echo everything that's already been said. I think Kristen did a really nice job of describing the sort of historical relationship between semiconductor companies and automakers, and that it wasn't a very well connected, integrated relationship. It was more of a tier 2, tier 3 relationship. And the nature of that relationship, I think, has really changed dramatically over the last couple of years. We spent a lot of time today talking about the growing level of technology collaboration between the semiconductor industry and the automotive industry. And what that has led to is more of a tier 1 relationship. It's not that we're replacing the tier 1 suppliers, but it's that semiconductor companies are now much more involved in the technology planning, the product planning, the roadmap planning that the automakers are leading. And that has led to increased transparency we have more visibility into the automakers' needs and their roadmap. They now have more visibility into our supply chains and our roadmaps. And that different dynamic in terms of our relationship, and now being much more of a tier one relationship, I think will helpfully help avoid some of the supply chain constraints that we saw a couple of years ago.
Thanks, Andres. And Greg, you started the webinar and you'll end it for us.
Sure. I mean, I'd probably say that having looked at the supply chain for the last, I don't know, 10 years at this point, yeah, there's been a steady shift toward automakers collaborating with semiconductor companies much more directly. That's not new. I think the newer lines of communication, and as Kristen mentioned, new specific teams that are focused on this, that does seem to be a change. You also see these large scale announcements where you have automakers saying, we are going to be committing X number of dollars. For example, Stellantis committing $11.2 billion for semiconductors to ensure they have supply. You have GM's relationship with Global Foundries. You see these announcements coming out, which does indicate that there is public recognition that the automakers need to have a different kind of relationship, and that they want to have that relationship with the semiconductor companies. And the semiconductor companies are, of course, making sure that they are able to, or trying to make sure to meet those needs. I'd also say that one of the things I'm seeing, and this kind of goes back to the theme of innovation, is this closer relationship definitely is fostering more innovation. As automakers and semiconductor companies are talking more, they are much more aware of what their requirements are. And rather than semiconductor companies looking at this as, well, we'll just take a product that we've used in other industries that are maybe bigger scale, we'll just sell that and do what we need to. There's definitely more of a focus I've seen on collaboration and creating devices that meet the needs of next generation automotive products. So those are kind of some of the main things I'd say that I've seen in terms of big trends that are changing in how automakers and the semiconductor interact when it comes to the supply chain.
Thanks, Greg. This concludes our webinar. I want to again thank our excellent panelists, Andres, Fern, Greg, John, and Kristen. A lot of great information, really showing how much this partnership between the auto and chip industry is driving the advancements in technologies in both industries, and the growth in both industries. As a reminder, a recording of this webinar will be available on the SIA website, as well as a copy of the presentations. But again, thank you very much to the panelists, and we'll look forward to the next SIA webinar. Thank you.
Thank you.
All right, thanks so much.